بسم الله الرحمن الرحيم. مع حضراتكم محمد سعيد، physics teacher. نحاول ان شاء الله نحل مع بعض the first model exam in المعاصر book. نشوف كده الافكار مع بعض. The first problem: a car of mass 1200 kilogram is moving with a velocity 20 meter per second. If the driver used the brakes. طيب تعالى واحدة واحدة نحاول نفهم البروبلم. model exam number 1. problem number 1: a car moves with 20 meter per second. Its mass 1200 kilogram. If the driver used the brakes and the speed of the car decreased to 8 meter per second. يبقى عندنا VI, we have VI equals 20 meter per second. VF, final velocity, equals 8 meter per second. Then the average force acting on the car is, so force is required. دايما نبدأ حل البروبلم من المطلوب. هو عايزين F. F equals MA. ماس موجودة عندنا الماس. فاضل مين؟ A. اللي عندي في VI VF، تمام، وعندي التايم. هو بيقول لي التايم within 6 seconds. So we can calculate acceleration from the first equation. A equals VF minus VI over time. So A equals VF equals 8 minus 20 over 6. بالكالكوليتر ونحسبها هتطلع 2 متر بير سكند سكوير. دلوقتي بقى عندنا الاكسلريشن والماس. So F equals MA. We have mass and acceleration. Mass 1200 times -2. So F equals -2400 نيوتن. طيب هو هنا بيقول لي choose، موجود عندي 2400 نيوتن in the same direction of motion. 2400 نيوتن in the opposite direction of motion. طبعا we will choose choice B, 2400 newton in the opposite direction of motion, because we have negative sign and the driver used a brakes. Number 2: when an object moves on uniform circular path. An object moves in uniform circular path. The value of linear velocity. Value is the magnitude. It means the magnitude of linear velocity and the direction of linear velocity. We have learned that when the object moves in circular path, it's the magnitude of velocity, which is called linear velocity, is constant, but its direction only changes. So we'll choose the value of linear velocity constant, while direction of linear velocity variable. So we'll choose C, constant and variable. In the opposite graph, the relation between the net force, if acting on a body moving in a certain direction, and the displacement D. We have relation between force and displacement covered by the body in the direction of motion. So the total work done by this force. Work equals FD. We have force on y-axis and D on x-axis. If we have constant force acting on the body, so work equals FD. F times D. FD equals what? Area under the curve. So we can say that work equals area under the curve. So in this case, in our problem, work equals area under the curve. We can divide it into two shapes, triangle and rectangle. So if we want to calculate the work, we should calculate the area under the curve, the total area under the curve. So work equals area of triangle plus area of rectangle. Area of triangle equals half base, half times 3 times height, half base times height equals 15 Newton, plus area of rectangle from 3 to 6, so this part equals 3, length times width times 15 equals, we can calculate it, equals 67.5 joules. Another problem here, number 4. The opposite figure illustrates an object rotating in circular path under the effect of a centripetal force 100 Newton. So we have centripetal force equals 100 Newton. Mass of this object equals 1 kilogram, R equals 4 meters. So the periodic time, the only rule that has periodic time, V equals 2 by R over time. We have R, but we didn't have velocity. So first we will calculate the velocity from the other rule. We have Fc equals mv square over R. Fc 100 equals 1 kilogram times V square over R 4. So V square or V equals square root of 400 equals 20 meter per second. Now we get velocity. So V equals 2 by R over periodic time. So periodic time equals 2 by R over V. Periodic time equals 2 by times R4 over V 20. We can calculate T equals 1.26. 1.26 seconds. Okay. Problem number 5. Object is at height h from the ground, and its potential energy is 200 joules. 200 joules. If it falls to half is this height, then the change in its kinetic energy equals delta K equals, okay, the change in kinetic energy equals kinetic energy at position B minus kinetic energy at position A. Kinetic energy at position A equals 0. So delta KE, change in kinetic energy, equals kinetic energy at position B. And at position B, which is located in half the vertical height, we said that potential energy equals kinetic energy in this place. So mechanical energy at point A equals mechanical energy at point B, according to the law of conservation of energy. Mechanical energy at point A, potential plus kinetic. Kinetic equals 0, so potential energy at point A equals kinetic plus potential, and potential equals kinetic, so we can say that to kinetic energy. So potential energy at point A equals 200 equals to kinetic energy. So kinetic energy at point B equals 200 over 2 equals 100 joules. Number 6. If the ratio between the mass of body A to that of body B. نحول الكلام ل rules أو laws. The ratio between mass of body A, ratio between body A to that of body B equals 2 to 1. So we can say that MA equals to MB. And the ratio between the speed of body A to that of body B, ratio between speed of body A to that of body B equals 1 over 2. So we can say that 2 VA equals VB. VB equals 2 VA. Then the ratio between kinetic energy of body A to that of body B, TE of body A to that of body B equals kinetic energy of body A half MA VA square. Kinetic energy of body B half MB VB square. Half cancel with half, so equals, you can substitute MA equals to MB. So substitute MA to MB VA square over MB. Substitute VB to VA all power 2 to VA all power 2. MB cancel with MB. 2 VA square over 4 2 square 4 VA square. VA cancel with VA. 2 over 4 equals 1 over 2. 1 to 2. The third choice. Okay. Okay, another problem. Number 7. The opposite graph illustrates the relation between the centripetal force acting on a body of mass 2 kg. We have a body of mass 2 kg and the square of the linear velocity, the relation between F and V square. Then the radius of the uniform circular path of the body equals, we need to calculate the radius. Okay. FC equals mv square over r. We can choose any point at the graph. For example, this point. FC at this point equals 4 Newton. So we have FC equals 4 Newton. And in the same point, V square equals 4. V square equals 4. Then substitute FC equals 4 equals M to multiply V square. V square equals 4 over R. So R equals 4 cancel with 4 equals 2 meters. 2 meters. Another problem. If the periodic time of for the rotation of the Earth around the Sun is, you should know that there is a mistake. 365.25 days. This the year on Earth equals 365, not 265.25 days. Correct this number. 365.25 days. Problem number 8. Periodic time of the Earth around the Sun equals 365.25 days. And the distance between the center of the Sun and that of the Earth. Distance between Sun and Earth equals 1.496 times 10 to the power 11 meters. Then the centripetal acceleration of the Earth around the Sun. We need to calculate AC. Okay, AC equals V square over R. We have R, but we didn't have velocity. So V equals 2 by R over T. V equals 2 by times R, 1.496 times 10 to the power 11 over periodic time, but we should convert time from days into seconds. 365.25 days times 24 hours times 60 minutes times 60 seconds. We should calculate it, okay? 2 multiplied by 0.496 times 10 to the power 11 over 365.25 times 24 times 60 times 60. Okay, velocity equals 29,785.67 meter per second. Okay, now we can get AC V square over R equals 29,785.67 all power 2 over R 1.496 times 10 to the power 11 equals 29,785.67 square over 1.496 times 10 to the power 11 equals 0.0059. The first choice, we can convert it 5.6 times 10 to the power negative 3 meter per second square. Okay, the first choice. Question number 9. A child of mass 40 kg moves horizontally on skating surface. You should know that. He said that he moves horizontally. The child moves horizontally. Okay. On a skating surface. Then the work done by his weight when he moves a distance 20 meters. Work in this case, weight acts in this case. So the displacement of this child towards in the vertical direction is 0. D equals 0. So work equals Fg times D equals 0. So work equals 0 because the child moves in horizontal. Work done equals 0. Which of the following graphs represent the orbital velocity of a satellite orbiting a planet? Okay. Satellite orbit a planet. V equals square root G capital M capital over R. Okay. V, the first one, V and 1 over square root R. Okay. It's true. V is inversely proportional to square root R. The second choice is wrong. Also, the third choice, V is inversely proportional to square root of R, not R. V is directly proportional to the square of mass of the planet, not inversely proportional. So we will choose the first choice, A. 11. The opposite graph represents the relation between the momentum of two bodies, A, B, and the time. Illustrate which of the two bodies is affected by a force. Okay. The force, when a force acts upon an object, it should change its momentum as F equals delta B over delta T. So momentum should change. Delta means change. In the object A, the momentum is constant. Momentum is constant, which means the change in momentum equals 0. So force in this case equals 0. Object A, force equals 0 because momentum, the change in momentum equals 0. While in object B, momentum increases as time passes, which means that momentum changes. So there must be a force acting on upon the object B. Another problem, a crane truck is pulling another car. Number 12. On a horizontal road for distance of 1 kilometer. Okay. In this case, the tension force separated into two forces. or splitting in two forces. Force called Ft cosine 60 and another force that raises the car upward Ft sine 60. The car moves under the effect of this force. So work done equals Fd. In this case, the force that pulls the car equals Ft cosine 60 times displacement. Work equals 10 power 5.